I'm Yvonne, and we're going to be looking at the Calc AB FRQ question from 2004, number 3. So looking at the problem, we can see that it states that a particle moves along the y-axis so that its velocity v at time t is greater than 0 is given by v of t is equal to 1 minus tan inverse of et at time is equal to 0. S of t is negative 1. Now looking at part A, it says to find the acceleration of the particle at time t. Now acceleration, as I explained earlier, is v prime of t, or the derivative of v. Now v being 1 minus tan inverse of e of t, we can differentiate this function easily using the chain rule. So v prime of t would equal derivative of 1, which is 0, minus the derivative of tan inverse e to the t, which is a compound function, making us use the chain rule, which states that we must first differentiate the outside function, and we do this by 1 over 1 plus quantity e to the t squared times the derivative of the inside, which is e to the t. Now we plug in 2, as we need to find acceleration at time 2, and we get negative 1 over 1 plus e squared times e squared. Now this being a calculator problem, we can plug it in and get negative 0.133. Now we're going to look at part B. So part B is asking whether the speed of the particle is increasing or decreasing at time t. And if the speed is increasing, the velocity at that t and acceleration must have same sign. But if the speed is decreasing, then v of t and a of t must have different signs. And we already know that a at 2 is equal to negative 1 over e squared plus e to the 8th, this being negative. Now v at 2 is equal to 1 minus tan inverse e squared. Now this being a calculator problem, we can use our calculator, and as you see, we already solved it and got a negative number. So this can conclude that the speed is increasing at time t is equal to 2, as the signs of v of t and a of t there are the same. Now looking at problem C, we must find a maximum of the position function. And to do this, we must look at the velocity function. So the velocity function, being the derivative of the position function, can be used to find the maximum of the position function. Velocity function being 1 minus tan inverse. Now we must find the zeros of this function, so we set it to equal to 0 and solve, getting us tangent inverse e of t equal to 1. We inverse both sides and get tan of 1 equal to t e to the t. We natural log both sides, getting us ln tan of 1 is equal to t. Now, we must prove that this, being the only critical value of v of t, is an absolute maximum. So a value is an absolute maximum if and only if its values, so if and only if it goes from increasing to decreasing. So the slopes go from positive to negative. So v of t is positive for all the values from 0 to this value, ln tangent of 1, and v is negative for all values after that. This signifies an absolute maximum as the function changes signs from the function v of t, changes signs from positive to negative and doesn't change later. Now, looking at the calculator, we must also find the decimal value for the value found in part C, approximately 0.443. Now, finally, for part D, we must find the position of the particle at time t and see if the particle is moving toward or away the origin. And to find the position, we must find s of t. Now, s of t is the integral of v of t. Now, it being the integral, we must integrate the function from 0 to 2 to find the total distance traveled by the particle. Now, our velocity function being 1 minus tangent inverse e to the t. This being a hard function, we must use the calculator to solve this. Now we must also subtract 1 as the particle is starting out at the position -1 at 0. Now, finally, we must look and check if the particle is moving away or to the origin. Now, to do this, we must look at the signs of the velocity function and the position function. So if the particle is in the negative, moving in the negative direction and is in the negative territory, it is moving away from the origin. But if it's in the negative territory but moving positively, it's going to the origin. So knowing that at time t is equal to 2, velocity was negative, as you remember from the previous parts, and now getting position at 2 to be also negative, we know that the particle is moving away from origin.